now we're being asked to find the zeros and the multiplicities, and this is the same exact function that we had a little bit ago in the last problem. So let's first begin by testing to see if 1 is a 0. And remember, the test for 1 says add up the coefficients as you see them and determine whether these equal 0. Now when I add all these up, they equal -20, and that means 1 is not a 0 of this function. So now I want to determine or test whether -1 is a 0. This is the process where we change the sign of the coefficient on the odd degreed terms. So this 3 comes from a 5th degree term, that changes to a -3, but we keep the -16 at the same sign. We change the +5 to a -5, we keep the 90 positive. We change the -138 to a +138, add the 36 there at the end, and these are not equal to 0 either. And that means neither 1 nor -1 is a 0. And now if we kind of change gears and we look at the problem before, from number 68, okay, we know that -3 is a lower bound and 6 is an upper bound to the potential zeros that this function can have. So I'm going to go back and rewrite my function here. F of x is equal to 3x to the 5th plus la-di-da-di-da in the center plus 36 at the end. Now using the rational zero theorem, the factors of 3 are 1 and 3. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. And so if we start going through the synthetic division or the rational zero theorem to find out what is our list of potential candidates here, we're going to have each of these over 1. So that would be plus or minus 1, plus or minus 2, plus or minus 3. I would have plus or minus 4, 6, 9, 12, 18, and 36, but we just said that those are out of the bound. Now we could have 4, and we could have 6, but the -4 and the -6 fall below the lower bound. So I'm going to skip over these. Then I have each of these values over 3, so plus and minus 1/3, plus and minus 2/3. 3/3 is the same as 1, we've got it. 4/3 plus and minus 4/3. 6/3 is the same as 2. 9/3 is the same as 3. 12/3 is the same as 4. 18/3 is the same as 6, and then we're out of our range here. So these are our only potential zeros, and we already know from testing above that 1 and -1 don't work. Whew, that's a long way to go, but all we're trying to do here is narrow down our possibilities. So now it's time to start doing some synthetic division, and I'm going to write my original polynomial here, 3x to the 5th minus 16x to the 4th plus 5x cubed plus 90x squared minus 138x plus 36. I probably didn't need to write that plus sign there. And we know 1 and -1 don't work, so let's just start with 2. Bring down our leading number 3. 2 times 3 is 6, minus that 16 there gives us a -10. 2 times -10 is -20, plus 5 makes -15. 2 times -5 is -30, plus that 90 makes 60. 2 times 60 is 120, minus that -138 gives us -18. 2 times -18 is -36, plus that 36 makes 0, and we have a winner! And that means we can write f of x as x minus 2. Notice I put a minus in there because we found out that 2 is a 0, which means that x minus 2 is a factor. The original polynomial began with an x to the 5th power, so we will have 3x to the 4th minus 10x to the third minus 15x squared plus 60x minus 18. Now we need to break this baby down, and we're still going to work with potentially that same list of zeros. And so here we go with some synthetic division. Here we go. 3, negative 10, negative 15, 60, and negative 18. And it's possible that 2 is a 0 another time, having a multiplicity of 2. So let's try it again. Bring down the 3. 2 times 3 is 6, minus that 10 makes negative 4. 2 times negative 4 is negative 8, minus that 15 makes negative 23. 2 times negative 23 is negative 46, plus that 60 makes 14. And 2 times 14 is 28, minus 18 is 10. So no, 2 does not work. So let's try negative 2, just working our way through the list. Bring down the 3. Negative 2 times 3 is negative 6, minus the 10 at the top is negative 16. Negative 2 times negative 16 is 32, minus that 15 is 17. Negative 2 times 17 is negative 34, plus that 60 up top is 26. Negative 2 times 26 is negative 52, minus that 18 makes negative 70, not 0, so that is a dead end again. So it's time to move on to 3. Bring down our leading coefficient to 3. 3 times 3 is 9, minus that 10 is negative 1. 3 times negative 1 is negative 3, minus that 15 up there is negative 18. 3 times negative 18 is negative 54, plus that 60 makes 6. 3 times 6 is 18, minus 18 is 0. Ding, 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 we've got a winner. So that means we have f of x is equal to the x minus 2, which we had before, and now we have x minus 3, which we get from changing the sign from the 0 to the factored form. And we will be left with 3x to the third minus x squared minus 18x plus 6. Oh boy. Now we look at this, and we can keep doing synthetic division, but I notice that the first terms are in a 3 to 1 ratio, and 18 to 6 is a 3 to 1 ratio, so I'm going to go with the grouping method of factoring. I'm going to factor an x squared out of the first two terms, and be left with 3x minus 1, 3x minus 1. And I'm going to factor out a negative 6 from the second two terms and get a 3x minus 1 again. And that means that f of x can be factored into x minus 2 times x minus 3 times 3x minus 1 times x squared minus 6. And the directions said to find the zeros, and so here we go. The zeros are 2, 3, 1/3, root 6, and negative root 6, and all have a multiplicity of 1.